Hey, Algebra 2 people. I'm going to talk to you today about solving some nonlinear systems. Just as a quick review, to solve a linear system, I'm interested in where one line and another line intersect. Well, again, as we said, if two lines intersect, they can only intersect at one point. Right? But now let's take a look. What happens if I have graphs that are more than just lines? Well, what are the functions that we've talked about so far this year that we could put into a system? Well, let's see here. I know that we've talked about parabolas, so I could have a parabola. Again, I've talked about lines, so let me put the line back in there. I could talk about lines. And I could have absolute values, so let's put an absolute value in there, right? Aren't these the three functions that we have that we can create a system of equations with? So, let's take a look at this. Suppose I want to first make a system of, say, let's see, a quadratic, right? And a line as my system, right? Well, if I did that, what would be the different scenarios? Well, I could have the parabola coming like this. I could have the line. Let me change this slightly. And again, this line goes on forever, so even though it doesn't show it intersecting, I still have to assume that it keeps going forever so that it will intersect. Would you agree you could have a quadratic line? Could you have 2 points of intersection that I would have to find? Right? Well, that's one idea that I could have for the system. Let me clone this guy. What else could I have? Well, could I have it so that this line only touches the parabola at a single point? So if you had this, would you agree there could be only one solution, where the parabola and the line intersect? So we had 2 solutions here, one solution here, and then for the last one, couldn't you actually have, well gosh, the parabola and the line just not even touching at all, right? So let's see what that would look like, right? You have something like this. Well, let me just modify this first picture, and you guys can draw that. Couldn't you have a picture that looks something like this? Couldn't you have a solution or a system that looks like this, where the parabola and the line never touch? So there'd be no solution, right? Now, one way to do this is by graphing. If I do tell you to graph a system and solve it, where you have a parabola and a line, I'll probably let you use your calculator. So let me show you an example of that. All right, so take a look at this. I want to solve this system of equations. Well, the first function is some type of smiling parabola. We know that. The second function is y equals x plus 1. Well, that, again, that's a line with a positive slope, something that might look like that. So I'm thinking that it's probably going to be 2 points, but again, it could be 1 point or it could be no points, right? So let's take a look at what this looks like. To do this, I'm going to use my graphing calculator. So I take out my graphing calculator. I type both equations, the first equation into y1, the second equation into y2, and then I take a look at this graph. I hit zoom 6 because this is a standard algebra problem. There's the first equation, that's my parabola. Here comes my line. And so as you can see, what I'm interested in, let me pull this over here, is I'm interested in this coordinate here and this coordinate here, correct? Well, gosh, that one looks like that might be 0, 1, and this one looks like it might be 3, -3, -2. But let's make sure. How do I find that on my calculator? Again, so to figure out something from a graph, I always hit second trace to call Charlotte. I summons her. Now I want to find the intersection 5. Now again, if I want to find the intersection where Charlotte's blinking, all I do is hit enter 3 times. So I get the intersection to be 0, 1. So again, I was correct in assuming that one of the solutions is 0, 1. So this one is verified. Now let's use Charlotte to find the other intersection. So second trace, intersection is 5. But now I need to find this other intersection right there, right? So what I have to do is I have to move Charlotte closer to that intersection. If I don't, then she always finds the intersection that she's closest to. She's definitely closest to that intersection now, so hit enter 3 times. And, oh, there it is. So the second intersection is -3, -2. So indeed, the solution to the system is -3, -2, and 0, 1. And that's how I've solved that by graphing. All right? Now, how would I do this if I wanted to do this algebraically? In other words, if I didn't have a graphing calculator, or I didn't want to spend the time and energy graphing these out by hand. Well, let's take a look at this. Well, does it make sense of what I could do? Let me get rid of this graph. Actually, let me shrink this down. All right? Couldn't I use substitution or elimination? Well, again, substitution says if one of your variables is alone, for example, this y, couldn't I replace this x squared plus 4x in for this y right here? Wouldn't I create a new equation that says x squared plus 4x plus 1 equals x plus 1? And lo and behold, I've created one equation with one variable that it should be easy to solve. Again, because this is quadratic, I have to make one side 0, so I subtract the x and subtract the 1. I get x squared plus 3x. Oh, don't the 1's cancel? Equals to 0. Now I go through my methods for solving a quadratic. The first easiest method is SAT method. Well, since there's two different x terms that I can't combine, I can't SAT method. Then I try and factor. Well, what's the first type of factoring? GCF. Is there anything I can take out of these two terms? Yeah, I can take out an x. When you get x times x plus 3 equals 0. Well, by factoring equaling to 0, I know either the first factor equals 0 or the second factor equals 0. So if the first factor is 0, well, that's one of the answers, and the other one is x equals -3. Now, guys, listen to me. This is the important part. I'm not done. Remember, I'm finding a point where the parabola and the line intersect. In fact, I'm finding 2 points. I've only found the x-coordinates. I have to find the y-coordinates for both now. So don't I have to now go back into either one of the original equations and solve for y? Now don't forget, it doesn't matter which one I pick. So now I'm going to take this 0 that I just created. Let's make a little donut here. I'm going to plug him into this equation right here for that x. So wouldn't it get y equals 0 plus 1? So if you do, you get y equals 1 when I simplify. So I know that the line and the parabola intersected 0, 1. Well, gosh, isn't that what we just did graphically? We got that answer. Plugging in -3 for x the second time to find the other point, I get y equals -3 plus 1. So y equals -2. So the other point of intersection would be -3, -2. And I found the same points of intersection algebraically as I did graphically, right? So what does this mean? Well, if I want to solve a nonlinear system, I can either solve it by graphing the two functions and just finding the intersection. But again, if you don't have a graphing calculator, that might be hard to do. Or I can use my algebra skills. Substitution method is probably what most of you guys like to do. Again, since one of the functions already has y alone, it's easy to just substitute the other expression, in this case this x expression, in for the isolated y here, and create a single equation with a single letter, right? And then just solve. But don't forget that you've got to go ahead and find the other y value. Don't forget that if you're looking for a point, I don't know how many kids just find the x values here and here and call it a day, and then they get the problem wrong. Okay? One last way of doing this. If you like this, just watch now. I know that the elimination method says get rid of one of the variables by adding or subtracting the two equations together, right? So that one of the variables cancel, right? Well, take a look at this. Well, if you look, would you agree, if I subtracted this bottom equation from the top equation, in other words, if this became a negative y, that became a negative x, and that became a negative 1, watch what happens if I use the elimination method. On the left side, would you get y minus y is 0 equals. Well, here I've got x squared minus, well, there are no x squareds here, so that just stays x squared. 4x minus 1x is plus 3x, and 1 minus 1 is 0. Hey guys, do you see that I got the same equation that I got earlier when I used the substitution method? Now, guys, substitution is probably the safe, comfortable way to do these problems, but you can skip some steps by using the elimination method. If you do, you'll get the same answer. I hope this explains how to do solve a nonlinear system. Tomorrow in class, we'll talk about solving an absolute value function in a line. Talk to you later.